All right, hello everyone. Oh, okay, 5 seconds. Okay, hello everyone. Let me get my slides up. All right, welcome to PrestoCon Day. Really excited to be speaking here and excited to see all of you join. I'll start off with a little bit about me. So I'm Tim Meehan. I am the TSC chair of the Presto project. The TSC is the Technical Steering Committee. This is the committee that governs the technical body, and I help to guide that committee. I'm also a software engineer, so I've been working on the Presto project since 2018. First at Meta, I worked there for 5 years on Presto, and currently work at IBM, also on Presto. Just a little bit about myself. What's kept me for 6 years on Presto. So professionally at kind of like an abstract level, I really like hard challenges. So I like specifically a few kinds of things. So firstly, I like challenges that require trade-offs where you have many different options and you kind of have to evaluate multiple different trade-offs and choose the one that's most appropriate for most situations. So I find that there's a lot of those in data and big data, so that really keeps me interested and engaged. I also like interfaces and frameworks. So not just sort of like writing code, but also how the code interacts with broader ecosystems and users. And so I like both of those things. And there's also a lot of that in Presto as well. So I find that there's tons of challenges and solutions that Presto helps to provide, and so I just really enjoy the project. So that's a little bit about me. We're here at PrestoCon Day, so I just wanted to give a quick overview on what is Presto in case you're new to it. So Presto is a SQL query engine. It's open source and it's fast, reliable, and efficient at scale. So we'll try to unpack a few of these different things. I think the first important aspect about Presto is that it's not opinionated around where the data lives. So what that implies is that you can federate queries and kind of like choose where you want the data to live. So it doesn't make a strong opinion on where you should put your data. And so like you can join a MySQL table or a Kafka topic with data and distributed storage. That's all possible. And so because it's not opinionated, it's also very flexible as some of the industry as the industry changes and kind of like we collectively kind of like have a better understanding of what's a good way to organize a data lake. So the second, I think, is that Presto is very fast. So it's designed to be fast and interactive. So like this is kind of like what we might call the priority for Presto. I'll get into that in a little bit more detail later. Presto supports a single interface over multiple runtimes, so you can unify multiple tools into Presto. We'll also get into that a little bit more in depth. But one of the goals of Presto is to unify the interface so that you don't have to learn multiple different interfaces. And last but not least, Presto is open source. And so not only is the code open source, but meaning you can freely fork it and modify it, but also the community behind the code is an open community. So that means no matter what company or stakeholder you represent, you can have a seat at the table in the Presto community and influence its code and direction. So openness is a core principle of Presto. Not only is what we build important, but also how we build it. This is because we believe that the strongest projects have the strongest communities, and you really cannot have a strong community with a closed up project. So what are some of the key features of Presto? Just to recap, once again, high performance and low latency. Presto is designed to be, very efficient. Interactivity. So, with Presto, you can stream results, and, if you have a select query, you can get results kind of like, as they get processed by the query engine. There's no intermediate shuffle that sort of like gates that. We also have very robust batch support, both in the form of, Presto, as a streaming interactive engine, but also integrating with Presto on Spark, which I'll get into later. It's very, very highly scalable, meaning because it can scale from tens to thousands of worker nodes very efficiently, and it's also very reliable. It's used at very large scale deployments. We'll get into some of those later. But a lot of people use Presto, which means that there's a lot of eyeballs on the quality, and also some of the edge cases that make query engines fail. So let's take a second and discuss how do people actually use Presto. Well, so firstly, Presto can be used however you like, and it can be modified however you want, because it's open source. It's also very pluggable, meaning a core design of Presto is that the engine can be customized, through standard ways without having to fork the code. However, we do find that's really great for many particular use cases. I've highlighted a few of them here. So, and also, as I go through these examples, I'll also share my own personal use of Presto that I've had in the past, just to kind of like provide an example. So Presto is really great for dashboarding. If you have data in the data lake, and this is, kind of like added either real time or even through batch, you can very quickly create a dashboard that is powered by Presto to report on key metrics of that data. So as an example, when I used to support Presto in the Presto team at Meta, I'd create dashboards that reported on its reliability, and then I used Presto, basically using Presto to support Presto. You can also think of other use cases like marketing impressions, or like all sorts of business use cases where such information, having that readily available, might help your organization, have come to insights faster. It's also really good for business intelligence tools like Jupyter and Tableau. So you can set up, for example, set up a notebook and share it with others, and you can plug in parameters and really get customized insights. So just as an example, I would use a Jupyter notebook to support the internal data lake that powered Presto to handle common tasks. And we would use Presto to sort of like answer some of those, common tasks. Interactive exploration. So Presto can be used to interactively construct and refine queries so that you can understand the underlying data characteristics really well. Some examples could be troubleshooting machine learning workloads, workflows, or trying to understand, let's say, like outliers within a large data set, or trying to get like top heavy hitters, that sort of thing. So just as an example, I would use Presto to understand the workload that arrived in our Presto cluster so that I can infer, how to cost or scale the clusters that came in. Batch processing. Presto can be used as a cost-saving measure, since Spark uses a lot of resources for container isolation and materialized shuffle. So, to save money, where Spark ends up using a lot of resources, you can move some of that workload to Presto, just to make it a little bit more efficient. Or where such features become actually useful, for example, when the container isolation is actually very necessary, because like the cost of rerunning like a very large running batch job is very prohibitive, then you can also use Presto on Spark. So you can actually embed Presto inside of Spark, leverage those reliability features while not having to switch over to a different syntax and different semantics, different functions, and all that. So, I helped to support lots of different batch workload, and really saw the powerful cost savings that it drove in the data lake. Of course, there's a cost using both Spark and Presto because you have two different engines, but the cost savings was really quite large. Like you could never just move everything to Spark. It wouldn't be very cost efficient. And so finally, you can build data-driven apps to solve particular questions. So just as an example, we had a tool that would power data for reliability debugging purposes so that support engineers could quickly arrive at insights without lengthy investigations. So, using Presto to power that tool was really just as simple as writing a SQL query. So using, Presto to power certain data-driven applications can save a lot of time and effort. So these are some of the use cases. Let's go into the history of Presto real quick, since we're kind of like going over the basics. We'll start in 2012, 2013, where it was created at Facebook, now Meta, and open sourced. And at the time, it solved a real need that Meta had, which was that there were two engines, and both of them really were making kind of like the wrong trade-offs. Firstly, there was an engine called Peregrine, which was fast, but also just would give incorrect results. This eventually became Scuba, and it's a great engine for what it does, but the potential to have incorrect results only works out some of the time. So like there's just certain instances where that's just it's unacceptable to be off. The second one was Hive, and Hive made it kind of like a different trade-off. Hive was too slow for interactive queries and really only suitable for batch queries. And so Presto was developed basically to fill that niche. And so like many things, I think like the large data lake at Meta foreshadowed broader needs in the larger community because Presto ended up being used at many large tech companies and quickly gained adoption. And so, that was the story, I think, from 2014 to 2018. In 2019, unfortunately, due to tensions with the team at Meta and disagreements with the management over there, the creators of the project decided to fork the project, and interested parties, either ended up going with the fork or remained with the original project. So this ended up becoming something called Presto SQL, which was then rebranded as Trino. And so that they've been, sort of like pursuing a different direction. We're sort of like in the same space, but I think we have differences primarily around, like how to evolve the project, especially for great performance in data lakes. In 2020, we began to work on, later in that year, we ended up establishing the Linux Foundation and establishing formal open governance. And so, this is kind of like the governance we have today, where we are a foundation under the Linux Foundation. We have a technical steering committee and clear-cut rules for, how to move up in the project and how to join the governing board. And so, this has really become, a core part of our DNA. In 2020, we began to work on many of the fundamental challenges that face what we now call data lakehouse. It wasn't really called that at the time. Just going back into the foreshadowing of future needs, but a lot of these challenges included, fragmented engines, which is separating your OLAP versus your query. Presto, at the time had an engine called Raptor, which, attempted to kind of like, couple the OLAP storage with the compute. And so what we found is that didn't scale. And so we ended up having to, make it so that, we can use Presto both for these OLAP use cases and for your interactive query. Your real-time data, and then complexity and fragmentation of the different tools that you use in the different warehouse, which caused us to eventually embark on Presto and Spark so that we could unify, like the interface that you have into Spark so that you don't have to create a different tool. But chief among these projects, these are all like various different projects, but I think like kind of like the biggest and most important was we began our work on the Presto C++ engine, which is powered by VLOX. And so we started that in 2020. Last year, we announced our effort to create a new major release. We haven't had a major release through the life of the project, but we are beginning to work towards that. We announced that at PrestoCon, and the goal is actually to make C++ our default engine. So this is really a core part of our history, and I'm excited to share today that we have some updates on. I think Aditi is giving a talk on some benchmark results, and also I'll be talking a little bit about some supported use cases where you can give it a try right now. We'll take a second to talk about who uses Presto. There are hundreds of companies that use Presto right now to power their ad hoc and interactive analytics, also some batch. Today you'll hear from Adobe, who will share some of their key use cases that Presto powers. There's also a few more examples. There's Bolt, which is a ride-sharing company in Eastern Europe, which runs 100,000 daily queries on Presto on a 2 petabyte data lake. Meta, the numbers for Meta here, I'm pretty sure are off by a factor or two, but Meta has one of the largest data warehouses in the world, which uses Presto. Also, Uber, ByteDance, and Twilio have very, very large scale usage of Presto. So we talked about Presto, its history, what it's good for. Let's take a step back and just sort of like maybe talk about the landscape that we fit in. So what this chart is what's called the MAD landscape. So for those of you who are not familiar, MAD stands for Machine Learning, AI, and Data. A fellow by the name of Matt Turk, who's a VC who's active in AI and big data, decided to create a new landscape chart similar to the marketing landscape. So this is written by Matt Turk and his colleague at the time, Siobhan Zilis, from FirstMark. So it's I think a relatively popular landscape chart, and it's useful to just kind of like figure out roughly. I mean, it's not really quite precise, but you can kind of like figure out roughly what commercial vendor or open source project belongs to kind of like which category. At the time when this was created, it was based off of a very similar marketing and advertising landscape chart. Like this is how it looked in 2012. And so even in which is when the Presto project first started. And so even in 2012, I personally find it, kind of unmanageable. There's definitely stuff in there that I would just, kind of gloss over. I know some of these projects just because I know some of the employers, but there's also a lot of defunct projects in this landscape. So this is how things looked in 2012. So let's take a look at how things look today. And as you can see, it's MAD. There's no way that you can make out anything from this. So I'll help you out. This little arrow is where Presto is. It's in the query box inside under the open source infrastructure yellow line, or yellow orangish line. So I think the question is like, what can we possibly learn from an image like this? And I think that there's a few kind of like important things that we can learn without knowing all the details of what every single thing in these boxes are. So one thing that we can learn is that orange, yellowish horizontal slice where Presto lives, that grew a ton. And so I would argue that it grew at about the same rate as the surrounding projects. So like roughly at the same rate as the chart itself. It didn't shrink. I don't think it shrank. So I take this to mean that there's still kind of like a very valuable need for people to take off-the-shelf tools and open source and modify them however they want or need. So like open source definitely still matters. 12 years since we started making these kinds of charts. Secondly, of the projects that existed in 2012, about half of them don't exist in 2024. So, something happened that made them irrelevant in some way. And then of the rest that kind of stayed, a lot of them have dropped off in usage. So I'll go over two examples, and not to pick on these examples. This is just my personal opinion. And so I have a lot of respect for the people who develop these tools. But, through my own personal lens, I'll just add a little bit of commentary. The first is Uzi. Uzi dropped off. And so I think Uzi, is an example where it solved a very particular need, but it didn't address it solved kind of like the business need, but it didn't solve it in a way that was very user-friendly. And so like I personally worked with Uzi, I think back in 2014, 2015, and I found it to be very clunky. And the second one I'd like to look at is Pig. So Pig made it in this chart, but it hasn't had an active release since 2017. And if I were to speculate, I would speculate that's because people don't want to learn a procedural language. What Pig is it's like a kind of like a procedural language to work over distributed data. People don't want to learn a custom procedural language when they work with big data. They want to work with typical tools that they work with, either data frames or SQL. And so, Hive had HQL, which it's not SQL, but it's very SQL-like, and grew a lot more popular. So we have, I think some of the takeaways are we have lots of growth for projects that solve problems in different ways. And we have a much slower rate of projects declining. So to me, that the signals is that the field still isn't settled yet. There's lots of room for growth, and there's lots of room for, kind of like different needs to be solved, as they arrive. We haven't kind of like reached an age of consolidation yet. There's definitely no clear winner. So looking with that context of like the mad landscape and like the madness, no pun intended, of like the data infrastructure, where does Presto fit into that? And like what can help explain just the sheer volume of projects that have been developed? And so I think the story of the past decade is just the splitting up of the database, and it's been split up in a few different ways. So the first, I think the big one that's driven a lot of the kind of like the cost savings has been the splitting up of storage and compute. So you start off with enterprise data warehouses where these are coupled, and in order to scale them, you have to buy more compute, and it's a very costly endeavor. So cloud data warehouses come and allow you to decouple that. That comes with its own problems in that the data is locked inside of that cloud data warehouse vendor. But we'll get into like how that's also been decoupled in a second. So storage and compute really drove a lot of the cost savings, and Presto being kind of like really the top half of the database has been there since the beginning, prepared for that. The next is batch versus interactive. So, very soon after, kind of like around 20, when Presto and Impala were developed, we realized that you make different trade-offs for different needs that you have in a very, very large data lake. So for your batch, what you're really most interested in is the ability to scale reliably and have repeated successes in your batch jobs. So, things like container isolation, materialize shuffle, checkpointing, things which slow down the query but can give you good reliability are very important. Versus, Presto, the priority is, when it was developed, was interactivity and efficiency. And for that, you use streaming shuffle, you don't checkpoint. And you don't have isolation. What you do is you kind of like have multi-tenancy. And so, now we've split up the ingestion, or in an enterprise data warehouse, you use the same tool for ingestion as you have for your query. And for in these days, we've split them apart, so they're multiple tools. You have multiple table formats now. So I think the story of the past 5 years is that in this environment where we now have multiple tools and we've now split up the storage from the compute, you have kind of like this chaotic situation where the tools don't know how to talk to each other. And also the data, it isn't known to be prepared or not, because there's no concept of transactions. And so now table formats have arisen, like Iceberg and Delta Lake and Hoodie, which now bring you some of these data warehouse type features, including ACID transactions, consistency, and just overall interoperability, so that you get consistent results no matter who does the ingestion and who does the query, which wasn't true before. And then, really just over the past month or two, you've seen a lot of developments around further splitting up the cataloging aspect of the database. So like the cataloging of the tables and the table management metadata. We now have Databricks announcing the Unity catalog and Snowflake announcing the Polaris catalog. All these are efforts to kind of like provide a unified open source catalog. And so we can consider that to be split out as well. So, we live in this environment now where we split out all these different components, really largely driven by cost and efficiency. But what are the problems with this? And the biggest takeaway for me is that there's hundreds of projects that all work on different parts of our AI stack, and the complexity is incredible. Each implementation differs slightly, so you have lots of concepts and needs that are slightly similar, but kind of different. You also are, for the developers who are working on these projects, we're all kind of like fixing the same problems. There's just a ton of overlap, and so we're moving a little bit slower than we could because we're reinventing the wheel many times over. For the user, we now have lots and lots of different interfaces and quirks, and you have to learn a lot of different systems. And so really the question is how can a disaggregated database, which is what everyone is working towards, have a consistent interface? How can we hide this so that it's not a burden to the user? And this is my hand wavy and biased opinion, but I think that the solution is really further disaggregation, which might be counterintuitive, but I think selective consolidation, so consolidating on things such as Presto SQL for your interface, and consolidating on table formats for your storage and catalogs is quite important. And what this will bring is kind of like unification in parts that matter, which is the storage and the interface, and then diversity where appropriate to do things like OLAP ingestion, CDC, and batch ingestion and query. And so Presto is very suited for all of these things. Presto was among the first to integrate directly with Spark and unify the interface that you have into Spark. Presto also has been, essentially the first adopter for vLocs. And so as, kind of like the most important and most mature library for eval, we are very well suited for, integrating with other tools and providing that consistent interface into the data warehouse. So I think that this is an interesting future. Obviously, it can shake out very differently from how I described here, but to me, this seems like the trend that we're going towards, and I see us as really among probably the most serious project that is taking this direction seriously. And on that note, I'll give a quick update on our integration into vLocs and our C++ backend. As I mentioned, our goal is to make the C++ the default engine. And so we're working really quite hard on that. It's the area of development that has the most active, the amount of code and PRs that are going into it. And so, I'm excited to share that we do have a lot of new supported use cases. So we do have a few connectors that are supported, including the Hive connector for reads and writes, Iceberg for reads and with writes coming soon. And then also the TPCH connector. I would encourage you to go to our website, prestodb.io. We've added documentation that lists out all of these supported use cases and limitations. We'd really love to have you try them out. And if you use Kubernetes, we're actually going to be developing a Helm chart very soon as well, thanks to our friends at Denodo. So definitely stay tuned for all of that, and let us know how, if you try it out, let us know how it works. So, I also I think I'm running out of time here, but I'll give a quick update on some of the recent innovations in the community. We've spent a lot of the past year working on Iceberg and improving our level of Iceberg support. I shared a lot of these updates at the last PrestoCon in December, but just over the past 6 months, we now have support for the REST catalog, which is very important given the announcements from Databricks and Snowflake, which where we've announced different projects that all implement that REST spec from the Iceberg spec. And so like the REST catalog really seems to be the future for Iceberg integration. And so we now supporting it is now very important for Presto's future. So very excited about that. We've improved our filter pushdown support within Presto, and I'll have data caching support so that you can use it, to cache like interactive queries and dashboards. Materialized CTE support. We worked hard last year on, improving or actually implementing our support for materializing a repeated CTE. So there's many cases where this yields a substantial performance improvement, including TPCDS. Also spent a lot of time working on our history-based optimizer, hardening that and improving it. And we now have native support for Iceberg, as I mentioned in my last slide. So as I wrap up here, let's just take a quick stock of like how the community is doing, and quickly just look at the numbers. So we've had a 3 times growth in commits over the past 3 years, which I think is really incredible. We also have spent a lot of time just being responsive and making sure that pull requests and issues are closed very quickly. And so I think we can see this in the numbers where we're starting to close our pull requests and issues much faster. We've had an 80% growth in unique committers, over 1,000 contributors since the beginning of the project. And I think the largest increase in contributions was this past year. There's been 285 new PR submitters over the last year, and over 1,000 GitHub stars. So if all of this really excites you, I find this to be incredibly exciting. There's lots of different ways to get involved with the project. Firstly, just join the Slack channel. It not only just ask questions, but if you've developed experience, help others as well. We are a community, and we appreciate kind of like this, helping each other out. And so like, it doesn't have to be technical. It could be also from a user perspective on Slack. Contribute to the GitHub project if you're interested in giving back. Especially if you know Java or C++, there's tons of opportunities for contributing code. We've also added an updated contributing guide. So if you go to our README on the GitHub project, there's a very nice table of contents that was recently added where it gives you some suggestions on where to help out. So definitely check that out. We have 4 different working groups where we tackle very specific areas of focus within Presto. These are a really great opportunity to take a slice of Presto and work on that without kind of like having to work on the whole thing. And then also join the mailing list where there's lots of different announcements and different information that you might find useful. So I just wanted to take a moment to say thank you once again for joining. I'm very excited for the presentations that we have today, and hope to see you all in the chat soon.